Okay, and here's the second part of your assignment today. You have to solve these equations that have radicals, and as long as there's not a number in there, I'm just going to assume it's a 2. Okay, I'm not going to put it here. Now, when you're solving equations with radicals and the variables inside of a radical, here's what you're going to do, okay? You're going to kind of separate the radical just from the rest of the equation, okay? I'll just make kind of an imaginary wall right there. And any operation we have outside, we have to get rid of, because my job in the first part is just to get the radical by itself, okay? I can't have any operations outside the radical. Right now we have one. We have a plus 3. So the opposite of plus 3 is to minus 3. And then that's going to equal 5. Okay? And then there's nothing outside of the radical, so I just put 5. Now once we're to that point, to get rid of the radical, you're going to parenthesize each side. And the opposite of a square root is a second power. Okay? So then those cancel, and I have 2x minus 3. 5 to the second power means I take 5 times itself. It's not 5 times 2, it's just 2 5s multiplied. So that's 25. And then I just solve it from there. I just add 3 and then divide by 2. So 2x equals 28. So I divide by 2. And that's 14. So x equals 14. Okay, so there's your first answer. Okay, so again, here's my radical where it begins and ends, okay? And outside you have an operation, you have a minus 3, okay? Because remember, what I want to first do is get the radical so it's all by itself. So I got to get rid of that minus 3, I just plus 3. And that equals 5. So now the radical is all by itself, okay? So we're at 5, and now I can get rid of my radical. So I just raise both sides to the second power, because it's a square root. If it doesn't have there, it's a 2, so we get rid of it with the second power. And I have 4x minus 23 on that side. And then 5 to the second power means I just take 5 times 5, and that's 25. Okay, then I add the 23. 25 plus 23 is 48, and then I divide by 4, and I've got my answer. All these have just one answer you have to find. So 48 divided by 4 is 12. Okay. Okay, a little bit different on the next one. Here's a radical. That's where it starts. That's where it ends. Now you have two operations. You have a times 5 when it's in front, that means times, and then a plus 7. Remember, I got to get the radical. It just has x in there by itself. So we have to get rid of the plus 7 first. Okay, so I minus 7, that's 1. Okay, but I'm not done yet. Okay, because I've still got that operation of 5. So I've still got 5 dot square root of x. Okay. So again, there we are right there. Now if I have to do the opposite of times 5, that would be divide by 5. So I underline both sides and I put 5. So I had to do two things. I had to minus the 7 from the 8 to get 1. And then I had to take my 1 and divide it by the 5 right there. So 1 divided by 5, you can keep it as a fraction or you can write it as 0.2. And now down here I get rid of the radical. Okay, a square root would be a second power. So you have x, and then 0.2 to the second power would be 0.2 times 0.2, 0.04. Okay, next up, here's my radical where it begins and ends, kind of right there. And we have two operations. We have a plus 5 and a times by negative 2. So we got to isolate the radical, get that by itself. So we get rid of the plus 5 first by subtracting 5. Now I'm at negative 2, but we still have another operation, the times negative 2. So if I don't want it to have this side times by negative 2, I'm going to do the opposite and divide by negative 2. And now that radical will be by itself. We can come down here. Negative 2 divided by negative 2 is 1. And now you can eliminate your radical. So second, and then raise that to the second power, and you have x, and 1 to the second is 1. It's not 2, it'd be 1 times 1, because remember 1 to the second is 1 times itself. Okay, moving right along. Now we have a cubed root. That's not a 3 in front as a multiplier. Okay, it's not a 3 in front as a multiplier. So here's where my radical begins and ends. It has a 3 in it this time though. Now at first you see only one operation, a plus 3, but actually with the negative sign in front, that means it's a negative 1 in front of that. So we do have a multiplier. So first we undo the plus 3. By the way, my whole object is to get that radical by itself. So we got to undo the plus 3 and then undo the times negative 1. So I minus 3. That gives me negative 3. But I wouldn't be done then. I wouldn't have this as negative 3 because I still got to divide by negative 1. Okay? So I'm not ready to come down here yet because after I undo the operation of plus 3, we're going to have to divide that by the negative 1. Now the radical is by itself, so negative 3 divided by negative 3 is 3. Now, if I have a square root, I do a second power, but when I have that 3, instead of doing a second power, we do a third power. That cancels. 3 to the third, remember it means 3 times 3 times 3. Doesn't mean 3 times 3, it means 3 3's multiplied together, and that gives me 27. Okay. Next one, radical begins and ends right there. By the way, if you don't know if a number goes in the radical or if it's a multiplying number in front, come and ask me. Okay, I would be happy to divulge that information. So you have the square root of x plus 2. We got to get that isolated by itself. The only operation I have is the 3 in front, which means times, so I do the opposite of times, which is divide. Okay. And then now my radical's by itself. 6 divided by 3 would give me 2. Now I got to get rid of my radical. Before I can get into the stuff inside, you got to eliminate your radical. You can do that with a second power. So x plus 2 is now without the radical, and then 2 to the second, 2 times 2 is 4. Then I have minus 2, and x equals 2. Okay. Okay, I got 2 more. Again, radical begins here and ends here, okay? So we want to get that radical. All operations outside of the radical, we need to get rid of those. So all we have is a minus 3. So I add 3, and that takes me to 13. And I don't have a multiplying number, so I'm ready, okay? I can bring that 13 down here, because that's the only operation I have. I have undone it, and now we're at 13. Okay, so take both sides to the power of 2. So we have 4x plus 7. Remember, that's not 13 times 2. That's 13 times itself. Two 13s multiplied together. Gives me 169. Then I minus 7. That takes us to 162. Then divide by 4 and hope for the best. 40.5. You get a decimal, that's okay. Okay. Now, put a star on this one because this actually becomes an easy problem. Okay. Now, I know there's 2 radicals, so first, check for operations outside the radical. Nothing here, so we have a radical here. We have a radical here. There's no operations outside either one of them. Okay. If there are, when there's 2 radicals, it is really complicated. Your best bet would be to just cry, but there's not, okay? Neither radicals. So I'm ready to get rid of the radicals now at the same time. I just have to take both sides to the second power. And then that radical goes away and I just have 2x. And that radical goes away and I just have x plus 5. So really, now I solve for x. We'll subtract the 1x to get rid of it. So that's 1x, equals 5, and then 5 divided by 1 would just be 5, okay? So, now in your assignment, the last problem is going to be like that. You'll have two double radicals, okay, if you have to look back at this one, but all the rest of them is just a single radical. You're getting it by itself, so you can raise it to the second, and then it's just solving a basic equation, kind of. Let me know if you have any questions.